Hey, hope you're doing well here today. Got a new lesson for you, 2-5, completing the square. But first, I wanted to briefly go over two questions on your quiz because roughly a third of you missed a couple questions here. So let's make sure you understand it because you'll have a chapter test with more of it on. So real quick, you're multiplying two complex numbers, okay? Now, the simple way to do this, well, not the simple way to do it, but the one way you could do it is just to FOIL this, all right? Um, and remember, when you're foiling, you have to remember that if you get I squared, it's equal to -1. And anytime you're taking I times I, that is I squared, and so that will be -1. But the simple way to actually do this one is recognize that you're multiplying a number by its conjugate, a complex number by its conjugate. And if you do that, the shortcut is just to do a squared plus b squared, okay? Where a is the first part, which is 2 here, so it'd be 2 squared, okay? And b is the number in front of I, so that's 7. Okay, so it's 2 squared plus 7 squared. So if you square 7, that's 49. You square 2, that's 4. And so that ends up being 53. Okay? Now, if you FOIL it, well, you do 2 times 2 is 4. The outside terms is -14i. The inside terms is 14i. And the last term is 7i times -7i, which is -49i squared. Okay? Now, remember what I just said about I squared. It's -1. So that's plus 49, that's plus 4, that's equal to 53. All right, and I've done that many times, so if you missed that, you guys got to pay attention to the videos better. All right, now some of you are doing great, but some of you guys, watch the videos, please. Okay? Anyhow, here we go. A lot of you guys missed this one. I mean, this one, we've done a lot of times something like it. To get rid of an imaginary number in the denominator, which is what they want you to do, you need to multiply by that thing that I keep on saying called the conjugate. This is called the complex conjugate. Okay, so you have the same real part, you change the imaginary part. Okay? All right, and so when you multiply a number by its conjugate, remember you're going to do a squared plus b squared because the outside inside terms cancel. You get I squared, and so that becomes a -1. And so, well, anyhow, in this case, a squared is equal to 5, so you have 5 squared. And b squared, well, the number in front of I is 1, so it's 5 squared plus 1 squared. And on the top, you're just going to distribute the 13. Okay, you have to always use parentheses here. It's not just 13 times 5, it's 13 and also 13 times I, okay? And I made a little oopsie, so I have to fix it here. But that would be 65 plus 13i, and on the bottom we had 5 squared plus 1 squared, okay? Because it's a squared plus b squared. All right, now let's go ahead and reduce this here. So we have 25 plus 1, that makes 26. So we have 65 plus 13i all over 26. And now, I mean, it's good to stop and look at your answer choices to see which ones seem reasonable here. Okay, and you might not think any of these seem reasonable, and I don't even have D. Well, I kind of circled the right answer already there. But, see, you got to reduce 65 over 26, okay? And it could be 13 over 5, but really you're dividing both by 13, and you get 5 over 2 for this part, and then 13 over 26 reduces to a half, okay? So you have, because 13 goes into 26 twice, so that becomes a half I. And there you go. That's that one. And now let's move on to the next lesson, which is on completing the square. And completing the square is something that is, well, it's more theoretical, but it has its applications. And the reason why we do completing the square is to help us solve quadratic equations, all right, and actually come up with an ability to solve quadratic equations easier, which we'll talk about later. But anyhow, quadratic equations, remember, are equations that have x squared. So we're going to solve these types of equations by something called completing the square in this lesson. Okay, before we do completing the square, we got to review something called a perfect square trinomial. All right, now if one side of an equation is already a perfect square trinomial, you can just factor that and then proceed to use square roots of both sides to solve the equation. Now, what a perfect square trinomial looks like is where you have one term that's in front that's a perfect square, you have a constant term that's a perfect square, and the middle term is twice the square root of the first term and the last term, twice the product of the binomial's first and last terms. So, a squared plus 2ab plus b squared would factor into a plus b, the quantity squared. Okay? You would have a plus b twice, essentially. And visually, this is what it would look like. Okay? So you have a squared plus 2ab's plus b squared. Okay? So that the reason why they call it completing the square is because, well, it would actually form a square here if you put all the pieces together. Okay? And so this area model really represents a plus b. Okay, so a plus b would be this, because this is a on this side, and then this side here is b. Okay, by a plus b. Okay, so a plus b times a plus b is a plus b squared. All right, and we'll come back to this area model a little bit later. But first, let's look at this example one where we can already identify the fact that it is a perfect square trinomial. Why? Because you have x squared here, which is a perfect square, 36 here, which is also a perfect square, and the middle term is twice the square root of 36, okay, which is 6, okay, times the square root of x squared, which is x. So you have 2 times 6 times x, which is 12. So you might be wondering, how does this factor? Well, remember how I taught you how to factor these. Okay, so you could list the factors of x squared, x and x, list the factors of 36, 1, 36, so on, so on, so on. But when it's a perfect square trinomial, it factors by taking the square root of 36 and the square root of x squared, and the signs here are both going to be minus, okay? So it would actually factor into, and this is just, sorry, I forgot to click through this, but this proves that it's a perfect square trinomial, because we got perfect square, and you get the middle term there. All right, and so now we can factor this by taking the square root of x squared, putting it here, which is x, and the square root of 36, which is 6, putting it here, and the sign inside this binomial is always the same sign, okay, of this term right here, okay? So that's going to be the same sign here as here, okay? Now, once you have it factored, you see it's a quantity squared, and so you can actually solve this by square rooting both sides. All right, so if you take the square root of both sides, the square root of 9 is 3. You have to remember to put the plus or minus sign in, because any quadratic equation oftentimes has two answers. Okay, it only doesn't have two answers when it's plus or minus 0. Okay, so yes, you have to consider both cases, and then you would split up it into its cases and figure out the two x values. Okay, so x minus 6 equals 3 is the one possible solution, or x minus 6 equals negative 3. The plus or minus gets divided, so you can find your two solutions. Okay, so your two solutions, and you'd get these by adding 6 to both sides here and adding 6 to both sides here, and that would give you your two solutions, 3 and 9. So it's pretty simple if it's already a perfect square trinomial. However, if it's not a perfect square trinomial, we have to do something, and this is what is called completing the square. Okay, you are basically changing the constant term to make it into something that's factorable, and that is called completing the square. Okay, so the first step in doing this process is just to isolate the x squared plus bx part. Okay, once you have x squared plus bx isolated, what you're going to essentially do is half this bx term, just chop this in half, and that's going to be b over 2 and b over 2. Okay, so it would look like this. This would be the visual model of it. And you see there's missing this little chunk that prevents it from being a perfect square. See, this isn't a perfect square shape, but it almost is. In order to get this little chunk here, this little chunk, what it's missing is the area, okay, of this section here. And this area is, okay, remember area is length times width, so it's b over 2 times b over 2, or b over 2 squared. So anytime you are completing the square, what you're trying to do is complete this little chunk here. Okay, and this little chunk, yellow, there we go, that's a better color to use. This little chunk here is b over 2 squared. This is the key to completing the square. Take the coefficient, the number in front of x, cut it in half, and square it, and that will complete the square. All right, and so this is basically the procedure that you would want to run to if you have any questions, are confused. This is how you would do it for an equation here, how you would complete the square for an equation. All right, so first, before you complete the square, it has to be x squared. It can't be a number in front of x squared. If there is, what you have to do is divide all the terms by the number in front of x squared. And so I'll probably do that on another video, another problem, because that is a little bit lengthier. Once you divide by that number, you need to figure out what constant needs added to make a perfect squared trinomial. Okay, so you're going to divide the coefficient in front of x, that's the b part here, by 2 and square your results. That is the b over 2 squared. That gives you that chunk that I was talking about to create this perfect squared trinomial. And then what you have to do to keep the equation balanced is you have to add b over 2 squared to both sides of the equation. And then you could take this chunk here and factor it to give you, this becomes the perfect square trinomial, and now you can factor it into x plus b over 2 squared. And remember, really what b over 2 is just the part before you square it, okay? So it isn't that tricky once you see an example here. First, let's just try to create what number you would add here to complete the square. All right, so in order to complete the square here, you have to find b. Okay, so b is equal to 20. You have to take b over 2 and you square it to complete the square. So that's just 20 divided by 2 squared, which is 10 squared. Okay, and so that's equal to 100. So to complete the square here, what you would add is 100. Okay, so let's see if we got some slides here to progress through that and make it a little neater for you guys. Yes, so there we go. It's the same thing I just said with a little bit of different formatting. And so once you complete the square, now you got something that's factorable, and when something's factorable, you can use it to make a perfect square, a binomial squared, and you take the square root of x squared, which is x. This time it's a plus sign, okay, because that's a positive 20x, and the square root of 100 is 10. Okay, so b over 2 goes here, which is the square root of 100. All right, and so that's how you would use, how you would complete the square. Now let's actually do it with an equation. Okay, example 3. Here we go. We're doing it with an equation. All right, so first, if there's a constant term already there, you might think that this is already a perfect square trinomial. But you do have a perfect square, but the middle term is not 2 times the square root of x squared, which is x, times the square root of 1. So really, the middle term would have to be 2x here, but it's 4x. So this is not a perfect square trinomial, so you have to complete the square. So the first step you would do is you'd move the 1 over to the other side of the equation, just following those steps that I had outlined before. And now we have to figure out what number we would need to add to both sides to complete the square. So we have to do what? Well, you have to find b, you have to divide it by 2, and we have to square it. So b over 2 squared is equal to 4. That number we add to both sides of the equation. That is critical that you remember to add it to both sides of the equation. That will allow us to factor this into x, and then you square root of 4 is 2, so the quantity x plus 2 squared equals 3. Next, you can square root both sides to solve this equation. When you square root both sides, you get x plus 2 equals plus or minus the square root of 3. All right, and so, well, you can't really do anything with the square root of 3. You can't simplify it. You can't do anything with it. So your answer, you just move over the 2, so that becomes negative 2 on the right side. Your answer is negative 2 plus or minus the square root of 3. If you want to, you could split it up saying x equals negative 2 plus the square root of 3, and x equals negative 2 minus the square root of 3. And those would be your two answers to this quadratic equation. All right, so that's about it for this video. I hope you now know what completing the square is and how you can use it to solve quadratic equations. And we'll see you next time. Take care. Have a good day. Bye-bye.